So we went as far as question 5. So now we're on question 6. Tutorial sheet 1. Tutorial sheet 1. Question 6. I think the best one will be this one. So question 6, the letters of the word excellent. Of the word excellent are arranged in a random order. Find the probability that A, the same letter occurs at each end. Now, the only way we can have same letters occurring at each end is when we look at the letters that appear twice. So we have letters E. So if we fix E here, how many do we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9. So position 1, we put E. 2, 3, 4, 5, 6, 7, 8, 9. We put E here also. Then we'll have X, we'll have C, we'll have 1E, we'll have L, we'll have N, T, like that. So these positions here are fixed, fixed, fixed. So what's happening? You are only permuting these here. So because I'm permitting only those there, then we are saying we have 1, 2, 3, 4, 5, 6, 7. The ones in the middle. So 7 factorial. So the probability that E appears at the beginning and another E at the end is going to be 1, 2, 3, 4, 5, 6, 7. So we have 7 factorial there over, we have L which is appearing twice in the 7. So over 2 factorial, everything we divide by the overall which is 9 factorial over E is appearing 3 times. So we have 3 factorial and 2 factorial for L. This is just for E. Now remember, we can also have L, then 1, 2, 3, 4, 5, 6, 7, another L. Since we also have 2 L's, so meaning that the probability that we have L and then L again is going to be 7 factorial over, when you fix L's, remember all the E's will be in between. So the E's repeat over 9 factorial over 3 factorial, 2 factorial. So for the E's, we are getting, I can do the reciprocal of the things down there. I want to solve it in this manner. 3 factorial, 2 factorial over 9 factorial, so that this will go, and there we'll have, and there we'll have 7 factorial multiplied by 3 by 2 over 9 by 8 by 7 factorial. So this will go. So we'll get this guy.
Just come back if it's closed.
2 to 4. So we get 1 over 12 for that piece. I don't know if it's my network or what, because it's not connecting. Is it true? This is for the network just. Okay, so that this one will give us 1 over 12. Then we also have another one here. You can do the same. So this is 7 factorial over 3 factorial multiplied by 3 factorial, 2 factorial over 9 by 8 by 7 factorial. So this 3 and this 3 will cancel. So we get the 7 cancel. 2 reduce 8 to 4. So we have 1 over 9 by 4. This is 1 over 36. Now the probabilities of these, they will be the probability starting with E or starting and fixing L, which is the sum of the independent probabilities. 1 over 36. So we'll get 36 down, 12 into 36, 3 plus 1. So we get we get 4 over 36. And this is 1 over 9. That is the probability that was required there. Is that okay? Just give response. Is it visible and is it okay? Is it visible and is it okay?
Yes, it's visible.
Yes, it's okay.
Good. Next, we go to B. X, C is meaning find the probability that X, C, and N occur together in any order. So right. Okay, there's a hand from Charu. Charu, you can ask. Charu, is it a question? Okay, we can't hear you, so when you have network, we'll get your signal. Okay. So from the word excellent, we want to put X, C, and N together. And then from 9, we remain with 1, 2. So there's a question here. The previous board, why are we adding 2 probabilities found? The probabilities found, we are saying there are 2 possible ways of having. The question says, the same letter occurs at each end. Find the probability that the same letter occurs at each end. So we have E that can occur at each end because we have 3 E's, or L because we have 2 L's. So we add the probability of E appearing at each end plus the probability of L appearing at each end. So all means we add. Okay. Now here we put XCN together and then we remain with, from 9 we remain with 6. So we have 1, 2, 3, 4, 5, 6. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we are saying the probability that XCN appear together in any order and anywhere. So you must get that language. They occur together in any order, meaning that is a term fixed on its own. So we have 3 factorial for that part. Okay. And then after having 3 factorial for that part, then we have, now we have 1, 2, 3, 4, 5, 6, 7. Because that's one letter now that is moving around. And we have, so altogether we have 7 factorial over, in the XCN, nothing is common. But in these remaining ones here, we have E that is common. It appears 3 times, and the L appears twice. So that over 9 factorial over 3 factorial, 2 factorial. I forget that. So now we'll have this, we'll cancel that. So we get 7 factorial over 2 factorial multiplied by 3 factorial, 2 factorial over 9 factorial. Like that. Then this and that will cancel. And so we get 7 factorial by 3 by 2 over 9 by 8 by 7 factorial. So this cancels here. So we get 3 there, 2 there. So we get 1 over 12. Here there's nothing to add. That's our property that we get. So when XCN appear together in any order, anywhere. So first they make one letter, but that letter has 3 factorial combinations, meaning 6. And then nothing is repeating there, so we can't divide anything. Then we count it now as 1 plus the remaining 6. In the remaining 6, we have a repetition there. So now we get back and count it, and after counting the 6, we count that letter. So we have 7. Understood? So that we talk about C. The letters occur in alphabetical order. How many ways do we have of these guys occurring in alphabetical order? C, E, L, N, T, X. So I was going there. So I was starting the alphabet code. A, B, C, D. After I get okay, yeah. So we have this order here. How many ways can we have this order? This order can only appear once in all the combinations that we have. So you're saying the probability of having the alphabetical order is 1. Is 1 out of 9 factorial, 3 factorial, 2 factorial. Is 1 out of 9. Hey. Your calculators will give you these values. And they will give you, don't worry. So you punch in and you get the value of this. So there's only one way, because when you switch these E's there, remember wherever the E appears is 3 factorial over 3 factorial, because they're the same. The same with L. So we're saying the order is just 1 out of all the possibilities. It only makes sense if we say it's 1 out of all the possibilities. Unless you have any question, you want to go to question 7.
So I haven't understood what you just said about the 3 factorial, 3 factorial.
So we're saying, if we were to work on this in terms of calculations, because we don't want to switch this, it must be in alphabetical order. The alphabetical order here must start from down going to Z. So if we are saying these are the same, they can be in any way. Immediately you say so, the formula requires that if they are the same, you must divide by the number, meaning here we'll get 1 for that. You want to talk about L, there are 2, so it will be 2 factorial again over 2 factorial because they repeat, meaning that there will be nothing to allow us to calculate this. So we only have this way for us to have the alphabetical order, or else it will fail to be in the alphabetical. So that's the...
Excuse me, sir.
Yes, hello.
Can you run through question B again?
Question B?
Yeah.
Okay, question B is just XCN as 1 letter. So where there's XECN there, I can put A to take that position. And then the other 6. So that we have 1, 2, 3, 4, 5, 6. Plus the A itself, because A now is allowed to go at any position. So plus the A itself, meaning we have 7 factorial. Now in the 7 factorial, we have E that repeats, so 3 factorial. We also have L that repeats, so 2 factorial. Now this A here can be in any order, meaning that as we are switching it, it will also be bringing impact if you change from XCN to NCX. So we calculate how many ways it can affect. It can affect the 3 factorial times in the multiplication way, so that this becomes that numerator there over the total possibility, which is 9 factorial over 3 factorial, 2 factorial. Okay. As they are thinking about that, we go to question 7. 4 people are chosen at random from a group of 10 people, consisting of 4 men and 6 women. So you want to choose from a group of 10. This 10 has 6 women and 4 men. Okay. So you're choosing 4, meaning the sample space, the number of the sample space is 10, choose 4. This is equal to 10 factorial, 4 factorial, 6 factorial, which is 10 by 9 by 8 by 7 by 6 factorial over 4 by 3 by 2 by 6 factorial. So this cancels there. Then we get these 2 to cancel 8. This to reduce that guy. So 3 times 7 is 21 times 10 is 210. So 210 is the number of opposite outcomes. Then now we go to our questions. A. 3 of the women are sisters. So find the probability that the group chosen consists of 4 women. Meaning, so the probability that you have 4 women. Simple. How many are we choosing altogether? 4 people are chosen, and they're all women, meaning that 0 men. So you say from women are 6. So we say 6. Choose how many? Choose 4. Since you have gotten from women. And for men, there are 4. You choose 0 over 210. This is it, 6 factorial, 4 factorial, 2 factorial over 210. This is 6 by 5 by 4 factorial over 4 factorial by 2. So this will go 2 there, 1, 2 there, 3 over 210. So we'll get 15 over 210. I think 5 can go there, up 3 times, down 20 by 5, that's 100. So 40 by 5, that's 200. So 42. That's 42. So that's a probability for choosing 4 women. That's for A. For B, consists of 2 women and 2 men. So the probability that you have 2 women, you also have 2 men. This is now from 6 women, you choose 2. From 4 men, you choose 2. Over. The over, we don't leave it. So the 6 choose 2. This is just 6 factorial, 2 factorial, 4 factorial, multiplied by 4 factorial, 2 factorial, 2 factorial. Everything over 210. So this is 6 by 5 by 4 factorial, multiplied by 4 by 3 by 2 factorial over 2 factorial, 4 factorial by 2 factorial, 2 factorial. So this and that will cancel. This and that will cancel. Everything, remember, over 210. So we're getting 2 in 6, 3. That's 15 there. 2 in 4, 2. That's 6 there. So we have 15 multiplied by 6 over 210. So if we talk about 15, remember 15 can go in 210. I think that it can go. Because 15 can go in, I think it can go 14 times. If I'm not mistaken. 15, 210 divided by 15. Yeah, 14 times. So that now there 2 can go 3, 2 can go 7. So 3 over 7. Now the crucial one. This is when I need to understand the language. Find the probability that the group chosen includes the 3 sisters. Includes the 3 sisters. So if it includes the 3 sisters, three of the women are sisters. So what will happen is we are saying the probability that it includes the 3 sisters. So we are saying now we have 2 groups. Okay. From the sisters, all of them. Then the remaining ones, so we're remaining with 7. We just get 1 over 210. Because we only have 3 sisters and the group includes all the 3 sisters. So we'll say 3 sisters out of 3 sisters. So from that, you calculate now. So you'll get that 3 choose 3 will just give you 1. Then 7 choose 1 will give us 7 over 210. which is 1/30. Then has more men than women. So if there are more men than women, then the probability that men are more than women is going to be, remember, we are picking 4. So it's possible that from 4 men, we can pick all the 4, meaning there will be 0 from the women, or from 4 men, you can pick 3, meaning you only pick 1 from the women. Or if you pick next, they will be equal, because if you pick 2 from men, then you also pick 2 from women. So that is not the case. Everything over 210. So now you add because of the off. So you add, so you get 4 choose 4, that is just 1. Then 6 choose 0, that's 1, 2. So there we get 1 plus. 4 choose 3, that's 4. 6 choose 1, that's 6. So we get 24 over 210, which is 25 over 210. This can be reduced. If you take 5 there, it will go 5 times. If you take 5 here, it goes 40. I mean 42 times. This is 5 over 42. Now we can ask questions. Source question 7. Feel free, guys.
Sir, I was kindly asking if you can go back to question, is it question 7B? How are you getting 2, there I see 2 choose 6 choose 12, sorry, 6 choose 2 and close brackets, and then 4 choose 2 is equal to 6. Now the denominator is, how did you get 2 choose 2
here
choose 4? And sorry, yes, sure.
So here we're saying, since you are dealing with 6 choose 2, we have
Yes.
6 factorial over 2 factorial multiplied by 6 minus 2, which gives us 4.
Oh, okay.
Multiplied by 4 factorial, divided by 2 factorial, by 4 minus 2, which is 2 factorial.
Okay, thank you very much, sir.
Right. So do we have some more questions? No questions? Okay.
So how did you find the 6 factorial over 2 factorial, then 4 factorial? Isn't it not 6 minus 4, that's 2 factorial, then the 2 factorial as well?
Where? Which piece?
B, the one which has 6 factorial.
This one here.
Yes, now the bottom part.
The denominator. Look, what we have is 6 choose 2, which is 6 factorial over 2 factorial multiplied by 6 minus 2 factorial, which is 6 factorial over 2 factorial, 4 factorial. That's this one here. And then dot 4 choose 2 again, like that. I don't know if I understand your question.
Yes, sir. I've understood.
Okay, thank you. Okay. So now because we chose Zoom, we'll be we have to be cutting. So we can cut it has cut us, then we so quickly you robot and get back because I'm just clicking and then I'll get back.